Let's talk a little bit more about defining network API contracts. So I say here define explicit, formal, cross-programming language, API, as well as data contracts that you're going to have between your clients and your servers. Contracts defined via code do not work, do not do this. Let me explain what I mean by this bullet. For a while there, certain people were going out and they were saying you can produce contracts with a contract-first approach, where let's say you sit down with XML or JSON and you go and define the contract, or you can create the contract using what's sometimes referred to as a code-first approach, where you sit in your language of choice and let's say you define some class or some interface and the interface has methods in it and the methods take arguments, and then there's some tool usually that can look at that interface and then go and produce the XML or JSON contract. From my experience, the code-first approach to making a contract does not work. It sounds nice. For software developers, it's really what you want to do because we like to think in code. But the contract tends to have weird things about it that takes an implicit dependency on your language of choice. Let me give you an example. The date-time class can be null in Java. In Java, they have a date-time class and you can pass null. But in .NET, date-time is a value type, and so you can't pass null. So if I create an interface in, let's say, .NET, and I have a method that takes a date-time as an argument, when that gets turned into a contract, and then someone tries to call that or use that contract from Java code, they may try to pass in null for the date-time, but it'll throw an exception when it gets to the server because that can't be deserialized. Right? Or if the server's in Java, then null is possible for date-time, and the server may allow null to be passed and do something with that. But in C# or .NET code on the client, it's impossible to pass null for that. And so you must always pass a date-time. Right? In addition, languages have other things like support for templates and generics and maybe nullable data types. And these kinds of concepts don't always work across language boundaries. So when you do code first, you're implicitly using these things and you're not creating a contract by definition that can work across language boundaries. So I strongly discourage code-first approaches to contract. I strongly encourage formal contracts where you really think about the wire protocol and what is going to be sent across the wire, what that's going to look like, and make sure you come up with something that is easily amenable or work with lots of different programming languages out there. Now, there are starting to be some standard ways and open ways of doing this. So consider using openapis.org and Swagger.io. These are ways for you to create these contracts with some tools that are available. You can create them in XML or in YAML files, and then there's tooling available that can take these XML or YAML files and then can produce client libraries for lots of different programming languages. And these tools that allow you to define these contracts, they restrict you to the set of data types and features that are available across a large set of programming languages. So they help you produce these contracts in a way that's guaranteed to work across multiple programming languages. So I highly encourage the use of these for you. Then there's these tools available that create language-specific client libraries. But again, beware that what these client libraries do is they take a data type in your language of choice, they serialize it to some format, and then they send that across the wire. And then they take that information from the wire and they deserialize it. Again, the serialization and deserialization can have high resource consumption costs. It uses more RAM, it uses more CPU, and as I've said before, we've had some customers where 90% of their application code is being spent in this serialization, deserialization, other than doing real business logic work. So beware of that. There's many cross-language data transfer formats that are available. The kind of, default is JSON or XML, right? That guaranteed to work because it really is just textual strings that you're moving around. There are some other more compressed binary protocols that are available, or data transfer formats that are available, like Avro, protocol buffers, flat buffers, Thrift, bond, and really these things are a dime a dozen. There's like a new one popping up every month. So you can take a look at these. They always have pros and cons. Some are better in some scenarios than others. And really, think about what you're going to do here. And then you'll probably have to stick with whatever you come up with for many years in the future. I mean, you could have a new versioned API, which is really adding a new API that has a new data format. You can do things like that. But again, the important thing is that you think this stuff through from the beginning. Another aspect of that is my last bullet here. Consider embedding a version number in the data structure itself, so that when you're reading something across the wire, the server can say, oh look, somebody sent me a version 1 of this thing. I'll deserialize it this way. Oh, so the client sent me a version 7 of this thing. Well, then I will deserialize it this other way. Of course, the version number has to be kind of in a data transfer format agnostic way. Maybe it's the first couple bytes of the payload, or maybe it's in a header of an HTTP request, so that you can look at that and then you know what the payload is, so that you can deserialize it properly.